In our last lesson, we talked a little bit about how sine, cosine are connected to the coordinates, the x and y coordinates of a circular angle, specifically where the circular angle hits the unit circle. So we're going to rehash that just a little bit, and then we'll take it a bit further. The idea that we're working with here is at any angle in the unit circle, any theta there, the spot where that angle hits the unit circle, the coordinates of that point right there are connected to the sine and cosine of the angle, because what I've just made there is a right triangle where the leg opposite the angle, which we'll call theta, is the same as the y value of this coordinate, and the leg adjacent to the angle is the same as the x value of that coordinate. Well, if we set this up as a trig ratio, that means the sine of theta, the sine of this angle, is the opposite leg, that's y, over the hypotenuse, which is 1 because it's a unit circle. So the sine of theta is y, the cosine of theta is that x, because that's the adjacent over the hypotenuse. And worth pointing out that the tangent is the y value divided by the x value. So it actually depends on both the y and the x. And since we just said that sine is y and cosine is x, we can also say that tangent of any angle is equal to the sine of that angle divided by the cosine of that angle, which is going to be a very useful fraction to remember for next unit. So now that we've covered that, we've reminded ourselves that the sine is the y value, the cosine is the x value, and now we know the tangent is the fraction of the two. We can think about that unit circle passing through all the points in all 4 quadrants. And we can say, at any point here in the first quadrant, both the x value and the y value are positive. Well, that means that both the sine and the cosine, and also the fraction, y divided by x, everything's positive. So sine, cosine, tangent, they're all going to be positive in the first quadrant. All 4 of the ratios are tangent. All 3 of the ratios are positive in the first quadrant. On the other hand, when we move into the second quadrant, well, what happens here is we're going backwards. So the x values are going to be negative, while the y values are still positive because we are above the x-axis. So x is positive, y is negative. That means that although the sine is positive, because, x values are negative, y values are negative, so the sine is, I just said that backwards again. The x values are negative, the y values are positive in the second quadrant, which means the sine is positive, but the cosine is negative. And since the tangent is the fraction of sine over cosine, or y over x, if one of them is positive and the other is negative, tangent will be negative in the second quadrant also. In the third quadrant, where both the x and the y are negative, that means both sine and cosine are negative. But since the tangent is the fraction of one over the other, if they're both negative, well, we know when you divide a negative by a negative, the tangent will turn out positive. And in the fourth quadrant, we're back to having a positive x value, but the y value is negative because we're below the x-axis, which means the cosine is positive because that's the x value, but the sine is negative because of that negative there, and the tangent is negative because if one of the two is negative, then the whole fraction is negative. And so what we have is in the first quadrant, all of them are positive. In the second quadrant, only sine is positive. In the third quadrant, only tangent. And in the fourth quadrant, only cosine are positive. And there is a mnemonic to help us remember this, which is one of my favorite mnemonics of the year, going around first, second, third, fourth quadrants. All students take and some teachers put chem here, some put calc, I don't know, put whatever you want. So That helps you remember that in the first quadrant, all of them are positive, and by all of them, we mean all three ratios. In the second quadrant, S is for sine is positive, the rest are negative. In the third quadrant, it's just tangent, and in the fourth quadrant, it's just cosine. The next step here is to talk about, well, what about in between the quadrants? We mentioned this term the other day. Those are called quadrantal angles. Those are the angles that are exactly on the x-axis and y-axis. They're not exactly in any quadrant. What are the sines and cosines there? Are they positive or negative? They don't fit into all students take crack. Well, let's think about what those four quadrantal angles are. Really five, you'll see, because the first one is at 0, and then pi over 2, and then pi. I'm just going around the circle here. 0, pi over 2, pi, 3 pi over 2. And I'm going to put this one again, 2 pi. Even though 2 pi and 0 are the same thing, it's worth having them listed separately. You'll see why next week. So if we want to think about the sines and cosines there, we can think about the coordinates on the unit circle here. So if we have our unit circle, this coordinate right here at that 0 angle, 0 radians, also 0 degrees, is just 1 comma 0. So the cosine is 1, the sine is 0. By the way, that'll be the same thing at 2 pi, because remember, 2 pi points to the same place. 2 pi and 0 are coterminal, so they must have the same sine and the same cosine. And we can just fill in the other four coordinates, well, just by looking. That's 0, 1. So the cosine is 0, the sine is 1 at pi over 2. When we get to pi radians, our x value is now negative 1, and our y value is 0, so negative 1, 0. And at 3 pi over 2, our coordinate is 0, negative 1. Cosine 0 again, sine is negative 1. And these are things that are going to have to be memorized. What I want you to recognize is the pattern here, and we'll talk more about this pattern next week. The pattern for sine is that it starts at 0, right in the middle. Sorry about that. It starts at 0, right in the middle. And then it goes up to 1, back to 0, down to negative 1, back up to 0. So that's what sine does. 0, 1, 0, negative 1, 0. Whereas cosine starts up at the top, starts as high as it gets at 1, and it goes down to 0, farther down to negative 1, back up to 0, all the way up to 1. And so what we're going to talk about next week is how we can kind of think of those patterns as a graph. We'll get to that next week. One last thing to talk about this week, or this lesson. There are 3 other trig ratios. I don't know if you've ever heard of them. We've got sine, cosine, tangent down, but there are 3 partners to all of them. They're the reciprocals. We know that sine is the opposite leg over the hypotenuse. The cosecant, whose symbol is CSC, but we always read that as cosecant. Even though the symbol only has 3 letters, we read the whole word. The cosecant of an angle is the reciprocal of the sine. It's the hypotenuse over the opposite. And again, another way to think about that is the reciprocal of the sine. We know that the cosine is the adjacent leg over the hypotenuse, and the secant, again, the symbol is just SEC, but we read it out loud as secant. Don't ever call that sec or sec. It is the secant of angle A, is the reciprocal of the cosine, so that's the hypotenuse divided by the adjacent leg, or sometimes it's useful to write it as the reciprocal of the cosine. And then the tangent, we know, is the opposite leg over the adjacent leg, and its partner, its reciprocal, is called cotangent, which is just the reciprocal of that fraction, the adjacent over the hypotenuse, or we can write that as 1 over the tangent of A. And I know it's a little bit weird that the regular sine goes with the cosecant, and the cosine goes with the regular secant. I know that's a little bit backwards, but that's the way it works. One important note before I end this video: when we use these reciprocals, cosecant of A, it's the reciprocal of A, very, very important that the cosecant of angle A is the reciprocal of the sine of A, so 1 over sine of A. That is not the same thing as the inverse sine of A, which we know is called arcsine of A. Very, very important. These are not the same thing. We will get back to talking about arcsine a little bit later in the unit, but for now, we don't want to think about that. So very important not to confuse the two. Arcsine and inverse sine are the same thing, but those are very, very different from the reciprocal of the sine, which has its own name, that's called cosecant.